This lens costs $212,000. It can see objects from kilometers away. It doesn't matter if the environment is bright or dark. 1 hour of video on this camera can take up close to 1 terabyte of storage space. It can be controlled and operated remotely. You're looking at one of the most expensive cameras in the world. This lens doesn't seem like it was made here on Earth. Have you ever wondered why TV cameras are huge and ridiculously expensive? Why don't they use regular DSLR cameras that are much cheaper, more compact, lighter, easy to carry? You can change the lenses at any time, and they even record in 4K. Or are there a number of reasons why regular cameras won't serve that purpose? And that's why media companies are forced to use more complex, much more robust, and more expensive cameras. And that's exactly what we're going to find out today. When you see an extremely robust TV or cinema camera, one important thing you should know is that in the whole setup, the most expensive thing is the lens, not the camera itself. The lens can cost more than 53 times more than the camera itself. Along with that, the lens is also heavier than the camera. And there's a reason behind that. It's the lens that contains the entire complex arrangement to capture all the light that will be processed and turned into an image by the camera. But the biggest problem when filming large events or live performances is that you don't have much choice about where to place the camera. The environment or the setting will always dictate the possible locations for camera placement. On top of that, the cameras can never, under any circumstances, block the audience's view so that their experience is the best possible, no matter where they are. Additionally, it's common for the camera operator, as well as the camera itself, to be several meters away from the stage or the place where the action is happening. This means that the lens needs to have a high zoom capability to reach the stage. Or in other words, the lens needs to have a long focal length without the camera operator having to change lenses all the time. Along with that, camera operators need to zoom in and out extremely quickly in certain situations. In other words, the lens's zoom mechanism has to support very fast zoom movements. But it also has to be able to zoom in or out smoothly to create a more subtle and emotional scene. And the last and worst thing that can happen when you zoom extremely fast is the camera losing focus, which means that the lens has to be Parfocal, which means that the lens can maintain focus even during extremely fast zoom changes. To make matters worse, there are many situations where the lighting is far from ideal. The lights can be turned off several times during the show, or the entire show can be performed with very little light to create more drama. And the lens has to be able to capture all those moments in the finest detail and always deliver a sharp, high-quality image, which means that the lens aperture has to be much larger. And all of this, the zoom, the lens aperture, the focus, and other features, must always be within the camera operator's reach, so he can make adjustments and changes at any moment without losing focus on the scene being recorded. In other words, the camera must have adjustment controls. And finally, there's no point in having an advanced, expensive, and complex camera if all the images it produces come out shaky. In other words, the camera must have image stabilization. In summary, a TV camera lens must have a long focal length to be able to zoom in over long distances, a large lens aperture, variable zoom, image stabilization, a wide field of view, and adjustment controls for greater precision. When you put all these requirements together and try to find them all in a regular camera, all you get is a big disappointment. Practically all regular cameras do not have all these features. And that's why cameras and lenses specially made for this purpose are used, which are much more complex, much heavier, and also much more expensive. A Fujinon Ultra R107 lens, for example, costs $212,000. And these are the prices of some other top-of-the-line lenses. The reason for these high prices is the complex design of the lens itself, as well as the complicated manufacturing process and the high-quality components that are used. In addition to that, manufacturers apply the highest manufacturing standards, along with rigorous testing and thorough inspections, with special emphasis on the extremely high-quality glass, which is the primary element and goes through detailed human and computerized analysis and inspections. In addition to that, all the electronic components, the servo motors, all the high-quality glass elements, the complex alignment of all these glass elements of various sizes and shapes, which can be concave, convex, or flat, the entire casing, all the correction of light distortion caused by having to pass through all these different types of glass, and it ends up resulting in an extremely expensive and complex lens to make. The Fujinon UA107 lens, for example, can range from 8.6 millimeters up to 1,800 millimeters, which is impressive, and with aperture values ranging from f1.7 to f8. And if we wanted to reproduce the same image from the Fujinon on a full-frame sensor, the required focal length would go from 33 millimeters up to an impressive 7,200 millimeters. And to understand why the lens is so big, there's a formula that can help us understand. The formula for the entrance pupil diameter is equal to the focal length divided by the EF number. So a focal length of 900 millimeters and an aperture of 4.5 gives us a required optical diameter of 200 millimeters, which is why the lens is so big. There is a huge variety of camera types used in live broadcasts, but they all have features that you don't find in regular cameras. With emphasis on the weight, which is much higher compared to regular cameras, and the build quality, multiple buttons to avoid diving into vast menus and to make it easier to access the settings. Internal ND filters for exposure control in outdoor environments, and an output module with a fiber optic cable for transmitting the images recorded by the camera. The camera can also have its zoom, focus, lens aperture, and other functions adjusted remotely by the director in another room many meters away from the camera. With all these features, these cameras end up being much more robust, heavier, and obviously much more expensive. When you combine the camera, a lens like this, and other accessories, the total weight of the setup can easily exceed 48 kilograms. So a high-quality tripod that can support all that weight is absolutely essential. The weight and build quality of the tripod are also extremely important, since it's the tripod that absorbs all the vibrations and movements caused by the camera operator. And at the same time, it has to allow smooth and gentle movements for the camera that's on top of it. And the greater the zoom applied naturally, the more sensitive it will be to small accidental touches, which will make the image shake. So the tripod has to be very dense, solid, heavy, and robust to absorb all those vibrations. In addition to that, in these environments, it's always necessary for the camera to be moved constantly. That's why the tripod should also have wheels for greater convenience. Besides that, camera operators need to make adjustments to the camera's height at certain moments. So the tripod adjustment mechanism, which can also be motorized, has to be easy to reach and operate. The monitor is also very important, because it's through it that the operator adjusts things like scene framing, focus, and zoom. These monitors are always built to a very high standard, and they display high-resolution images in 4K or even 8K. With excellent contrast and color quality, they also offer manual controls for brightness, contrast, and more. There's always a red light on top of the monitor to indicate when the camera image is being used during the broadcast. In other words, the image that's appearing on TV is coming from it. Green signals that the director can switch to that camera at any time, This indicator light is called a tally light. One important thing during filming, you can't touch the lens directly to adjust the zoom or focus. Since any touch to the lens can throw the shot out of frame, it can also create small vibrations that might make the image shake. That's why cameras have controls for zoom and focus adjustments, which are always within reach of the camera operator. These controls are connected to the tripod for greater convenience. They offer easy and precise control for necessary adjustments during recording. A lot has been said, but it all comes down to a simple principle. In a typical setting, the environment must adjust to the camera's conditions. In other words, you can change the setting, you can adjust the lights, change items in the scene, redo the filming, switch lenses until you get the best result. But in a live broadcast environment, it's the camera that has to adapt to the conditions of the event. In other words, regardless of whether there's little light or the lights are completely off. Regardless of whether the camera is far away or close to the stage, the camera tends to always deliver a sharp, high quality, and excellent image. Because you only get one chance.